Hello and welcome to this walkthrough of this case, the Ironman case. This was part of the Excel World Championships in 2024, which was before my time as I only started doing this year in 2026. The usual caveats from me, I have gone through this case a few times already, so I'm now solving it using some things I've learned as I've gone through it, working out which approach works best. When I tried this first time, kind of under timed condition without any knowledge, my score was somewhere in the 500s. I think I may have got over 600 with one of the bonuses at the last minute, but yeah, certainly not even half marks overall. But having gone through the case now, it definitely, I can see that I think somebody might have solved this fully within the time. Perhaps it wouldn't completely surprise me, unlike some cases where I think how on earth would anyone have got that in the normal time. But yeah, enough whittering on. Let's get to it. I'm going to try, as I have been recently, trying to use my keyboard as much as possible, avoiding using the mouse where I can. But there'll be a few points where probably I will have to, because I either don't know the shortcut or I don't know how to do it. So yeah, let's get to it. Let's go to our timer and start our game. And our 30 seconds is on the clock. Okay, so the setup, I won't go through that. You would have, if you've done this case, you'll know what it is. So let's get straight to question one. So going to do some data prep. So we need to go to the competitors. Let's take all of this and use Shift Control F3 to name this based on the top rows. And I think for now, that's all I need to do for this. So we're going to XLOOKUP the competitor in the competitor list, and we want to return in this case the biking list. So we're going to use indirect because we've named those ranges. That means that will work. So let's copy that down and let's go to our score sheet. And we're good, 40 points, good start. Okay, next question. How long do the following competitors take to complete the swimming lap? So we need to find out their speed. So we'll do something very similar as we did before, looking up the competitor in the competitor list. This time we're only interested in swimming, so we can just put the named range in there. But that's their speed, so we need to find their time. So we're going to do the distance, which is 4 divided by the speed. But we need to round this to do decimal points. So let's go back in there and round that to 2 decimal points. And let's copy that down. And let's copy that over to the score sheet. And good to go. All level 2 done. Okay, let's go on to level 3. So how long do the following competitors take to complete the bike leg? So this is going to involve a bit more work. So I'm going to open up a data table. So let's start by looking up the player in the competitor list and returning the biking speed. And then this is where we actually need to look at the bike course because we have some issues here. So anywhere where it is grey, I'm going to fill this in as 1 because that's the standard speed. Anything where it's orange means it's uphill and they're going slower. And we were told in the introduction that that meant a speed only 0.7 of the normal speed. And anywhere that's green, which is downhill, it's going to be slightly quicker at 1.2. And what I'm going to do is I'm going to wrap this whole thing in rows. I need to give it a number of columns. And that's giving me my speeds on the left and my laps on the side, and I only really want the first column, so I'm going to say take that and take the first column, and I'm actually going to name that my bike lap so I can refer to that later. So let's go back to level 3. So let's take our bike lap and we want to multiply that by our speed. So that's the relative, the adjusted speed, or not bike lap, and that should be times. Okay, and then what we need to do, so that's our speed adjusted, and our time will be the distance divided by that. So each kilometer is 1 divided by that, which is our time. And if we add that up, we get a sum of that. But that's only for 1 lap, so we're going to do this 9 times. So let's multiply that by 9, which gives us 5.4 hours, which if we take that times it by 60, that gives us the mins, and if we round that to 0 decimal places, we get 325. And if we just reference that there in our data table and copy that over to level 3, and we're good to go. I know that took up a lot of space and we might regret that later, but that's fine for now. So level 4, assuming a start time of 6 AM, when do each of the following competitors complete the Ironman? So we now need to map out or model out the entire course. So I'm going to start off with my data table for level 4, but what I'm going to do is I'm going to take the work I did in level 3. So in level 3 we did actually we only need the first 5 columns because we need the total time in hours. So I'm going to select all of those columns, copy them, go to my level 4, go into column E and paste that there. So now that is our bike time there. So now we just need to add the swim and the run. And we've done the work on this before, but we'll just quickly do it again. So the swim is 4 divided by the X lookup of the player in the competitor list in the swimming, and that gives us the swimming hours. And then our running, in fact we can probably just paste this over and adjust, so we'll change it to biking, and the competitor is in B1 and the distance is 42 kilometers. So if we sum those, or not all of those, that's the total, which if we then, so that gives us 8 hours, just double checking that. Bike 6 hours, swim, that does seem about right. So we want how much of that as part of a day. So the total number of hours divided by 24, and then we need to take that and we need to add 6 hours to it. And then we need to put that back into minutes. So let's say text of that time in HHMM. Something's gone wrong. What have I done wrong? That's the sum. We times that by 9. That's the swimming. Oh, I can see where I've gone wrong. It's not biking, it's running. There we go, 1746. So let's just multiply that by 1. And there we are, good to go. Panic over. Probably some of you saw that mistake happening as it was going on. Level 4, all good to go. Okay, let's go back to get to level 5. So level 5, after 5 hours, how many kilometers have the following competitors traveled? So now we're going to have to not just map out the total times, but actually per kilometer. So this involves a lot more work. And so what we're going to do is let's get all of the details relating to the player. So we need the swimming, we need the biking, and we need the running. And so what we're going to do is we're going to X look up the player, and I'm going to lock that in place. We're going to look them up in the competitor, and we're going to return the indirect of what's above us. And then we're going to fill that to the right. So that gives us our speeds for each one. So the next thing we're going to do is we're going to work out the kilometers. So we're going to, how many kilometers are in the total? Well, it's the sum of 4 plus 180 plus 42, which is so those represent our kilometers. And now we need to work out what are our actions. So what are we actually doing at each one? So for the first 4 kilometers we're swimming, then 4 plus 180 is biking, and then 184 plus 42 is running, which is our 226. So what I'm going to say is I'm going to say X look up this number in this range and return this range, and we want to say the exact match or the next smaller item. Nope, always get that wrong. Should have been the next larger item. Yes, so swimming for 4, then we're biking, and then we're running. Okay, so that's what we're doing. So then what's our initial speed? Well, we're going to X look up what we're doing in here, and we're going to return our speed from here. But for biking, our speed needs to be adjusted. So our speed, our actual speed, which we'll call speed 2, the sequel. So if this equals biking, then we've got to do something different. So what we have to do is we need to find out what lap we're on. So we're going to, for now, just take the kilometer -4, so we remove the first 4 miles, otherwise we're going to return 1. Okay, so then we see for biking we're going down, but we now need that to loop into laps. So let's put this into a mod. So let's mod that, and I'm going to -1 inside the number, mod it by 20, and then add that 1 back on, and now we see we're lapping round, and this is where we're going to use our bike lap again. So what I'm going to do is I'm going to lookup. In fact, I'm not going to use it. I'm going to index into the bike lap to that number, and now we've got the speed, and if it's not biking then we've just got 1, so our speed has now been adjusted. So now our time equals the distance, which is always 1 divided by the speed. So that is our, nope, wrong one. It's not by, let me try that again. We need to do our, so that's not our speed 2, that's actually a multiplier, isn't it? This will be speed 2. So our speed is actually that times our multiplier, and then our time is going to be that, 1 divided by that. So that's our time for each one. So we want our running time to, we'll scan through starting from 0 through that, will sum. So now we've got our actual time. So that's mapped out the whole thing, but we've got to work out where we are after 5 hours. So what we're going to do is, where are we after 5 hours? So we're going to look up 5 in this column, so our running total, and return the kilometer. And I think we're going to go -1 because we want to find the one before it. So let's just check that. So 140, so at 140, as we can see, 4.97, at 141 we go over. So we've got a little bit left. We've got a little bit of time left after we've reached 140. So that's going to be important for this next bit. So our next kilometer is just 140 plus 1. So we want to work out how much time is remaining. So we want to look up our kilometer 140 in our kilometers and return the time. So we reached 4.97. So what do we have left? Well, it's that, but we take that away from 5. So that's how much time we have left. And then we need to know the speed we go during the next kilometer, because it might not be the same as the current kilometer. So we'll look up kilometer 141 into the, oh, I've done that wrong, G6, G7 hash, and look up the speed. So our speed there is 24. So how much distance will we cover in that next little bit of time? So that 0.02 of an hour. So distance is speed times time, which is 0.69. So our total is that plus that. So 140 complete kilometers plus that little bit. Oh, I think I've done something wrong there. That plus, oops, oh, something gone wrong there. Let's start again. So equals that plus that, which gives 140. And if we round that, so let's round that to 1 decimal place, 140.7, which is what we're expecting. So let's take that, let's copy those over to level 5, and we're good to go. Okay, let's go back to level 6. So level 6 is, we can use the work we've done. So it says after 7 hours, which competitors are in the following positions for the race. So we need the same work, change our 5 to 7s, but then work out the order. So what I'm going to do is I'm going to take level 5 and I'm going to make a copy of it. I'm going to call this level 6 just for neatness sake. Let's get rid of this data table for now, so because we're not actually going to use that. So all we're going to change here is the X lookup will be based on 7 and the remainder will be based on 7. And if I was really smart, I'd have set a single variable that does this, but never mind. And then instead of our examples, we're now going to use our competitor list, and we're going to data table that, and our input is going to be based on the name this time rather than the lookup, and that gives us all of the times. And then what we want to do is we want to sort by the competitors by the times, and distance is more is better, so we want to go in descending order. And we're getting something slightly wrong there because Nick Loman is meant to be 5th from the example. So what have we done wrong? So we're looking up 7. We don't want to round, so let's get rid of that. Let's take that equals the actual total, and that looks better. Okay, so let's go back to the case. So let's index into that list. Let's fix that reference and then index this much. And then let's fill that down. And let's go to score sheet for level 6. And we're good. Okay, so actually I found that, I mean, if you've done level 5 well, then level 6 kind of follows on quite naturally. Right. Level 7. Turns out this Ironman's time, and after completing 100 kilometers, the pace decreases every 20 kilometers. Okay, so we're going to build on some of the work we've already done, but we're also going to do some new work. So our level 5 model should be sufficient. So we'll copy this in a moment, but for now, let's build a data table based on level 7. Let's go to level 5. So we need everything from column E, I'm going to say columns E through to M. So we'll copy that, go to level 7 and paste that there. So for now, that's good. The only thing we've added in is this deterioration. So basically, I'm going to create a little lookup here. So I'm going to create a sequence of, I think 8 is all I need. We'll see where I start at 101. Because it's the 100th, but the 100th kilometer is still at the old rate, so 101 is the start, and then we want every 20 a step of 20. Actually, I don't think I needed 8, that's fine. And we'll put 1 above that manually, and we start with a multiple of 1, but then what we do is we then take this above it and we multiply it by 1 minus our multiplier. Let's fix that in place. And then let's fill that down. So that is our kind of lookup. And then what we're going to do is we're going to add a second multiple where we say X lookup the kilometer in our table here and return the multiplier. But if it doesn't find it, we need, so if we're on 2, we want to go back down to 1. So we want the next smaller, which is -1. Let's just double check that. So we start at 101. Yep, that's good. And then our multiplier, our speed, just now needs to include that multiple of the N7 hash. And that should give us our answer. Although we don't actually have our answer yet, because what do we need? We need to sum the time. We get 14.35, which if we round that to 1 decimal place gives us 14.4, which is our expected answer. So let's copy those into our level 7 score sheet and we're good to go. So that's levels 1 to 7. We've used all 19 minutes. Okay, let's speed up a little bit. So let's get back to here. So question 1 on the bonuses. The competitor managed to complete exactly 1.5 laps of the running leg before giving out how many kilometers did they complete. So they've done the 4 swimming plus the 180 cycling, but then they do only 1.5 times this 42 divided by 5, which is the total. So we get 196. How many kilometers of the bike leg are competitors either climbing or descending? So in our bike course, there's only 1, 2, 3, 6 where they're flat. There's 20 in total, so 20 minus 6 is 14. So we will say it's 14 kilometers, but there's 9 laps, so that should be 126. Excluding examples in the answers to level 6, how many competitors do not feature in the questions below? So we need to quickly get all the competitors. I'm sure there's a way of doing this formulaically, but for now, I'm just, by the time I've worked out what it is, probably just quicker to copy them over. Again, this is a bit of manual work, which I don't like, but there we are. Let's get this quickly done. And we're almost there, level 5, and then we don't need to worry about level 6, and then level 7. Which I probably could have copied just the whole of that column, never mind. Okay, so we need to know, count how many unique values there are in there, and there are count how many competitors there were. So it's that minus that, which is 63. 63. Disregarding the new parameter introduced in level 7, who actually won the race? So let's use our level 5 model. That's level 5. Okay, let's make a copy of this, and let's remove the data table. Don't need to worry about that. We just want to know the total time, and we then want to do that for every competitor. So let's go competitor and then equals that, and then data table that based on the name, and then we want to find the shortest time. So let's look up 0 in there and return that, but we want exact match or next larger item, which gives us Brian Hanley, which we'll paste in here. And then under level 7 rules, and assuming a performance decline factor for all competitors of 5%, how many of the 129 competitors finish the race within 12 hours? So let's use our level 7 model. Let's make a copy. Similarly, we're going to not be using different question numbers, and we're going to want to keep this fixed. So let's just copy that as values for now. And then let's put all the competitors here. So we want to know the total time. Let's make sure it's not rounded. So let's use this one. And then let's do a data table. And we're basing this on B1. And then we want to know how many of these are over 12. No, under 12. Count ifs that is under 12, which gives us 77. And let's just copy all of those over here to our bonuses. And we have to wait a little while, but hopefully I'm fairly confident those are good to go. And we are done. And we've got 1250. Stop solving early. So what was that? 2250. There was obviously, I did mess up somewhere in the middle. There was somewhere where I got annoyed that I had done something wrong, and I can't even remember what it was that I did wrong now. But yeah, that was obviously, like I said, I've gone through a few times, so wouldn't have had a hope in hell of doing that in the live case. For the live case, or not live case, I wasn't completely live, but when I did this as live for the first time, I managed level 1, did level 2, did level 3, managed level 4, and then level 5, I got some of level 5, and I basically what I remember doing was I tried to map out all of the kilometers, but because we were rounding to one decimal place and I didn't know how to deal with the fact that you reached the limit and then only needed part of a kilometer for the final one, what I actually did was I mapped out every tenth of a kilometer. So I had kind of things stacking and stacking. So I was hoping I would get nearer. But I think even then, sometimes I was still, on half the time, I was still too far away because it was still rounding within half. So what I should have done, if that was the approach I wanted to take, I should have actually done every fifth of a kilometer, or even every I was doing every 10th. I would have needed to every 20th, or maybe the easiest way, not the easiest, but if I wanted to take that approach, I should have done every 100th. But as you can see, I've now found an approach that, or I say I found an approach I've seen used, I've adapted, that works perfectly well by just then dealing with the last bit of a kilometre individually, rather than trying to map out every 10th or 100th of a mile. And then I think I managed to get a couple of the bonuses, and yeah, so that was how I did. So yeah, hopefully, well, don't know who's watching this, but as I've said before, I'm doing this mainly for myself. I find it helpful. It forces me to really concentrate on what I'm doing and to explain what I'm doing and understand what I'm doing. So yeah, I hope you found that helpful. And obviously kudos to anyone else who, I know some other people have done some walkthroughs already, which are probably better and more clear than mine, but hey ho, there you go. Right, see you next time.